Hey guys, it's Brandy Crowley, and I'm going to talk to you about understanding and recalling basic number facts. Our kiddos have to understand the operations if we ever expect them to recall the basic facts. It's the foundation that we have to build everything on. Basic facts in addition and subtraction have one-digit add-ins, and then in multiplication and division, it usually has 1 to 2-digit factors. Our kiddos will benefit greatly from working together in cooperative groups. With this problem, 5 groups of 3, one student may teach the others about repeated addition, another kiddo may teach about groups, and another may teach about arrays, so that one kid that didn't understand now has heard it 3 different ways and hopefully picks one of those up. Related facts are so important. Our brains are pattern detectors. So if we're solving a problem like 4 plus 6 equals 10, we could think of 10 minus 6 as the same as 4. Or if we're thinking of 10 minus 6 and we don't know it, we could think, well, what plus 6 is 10? And we know that that's 4. Teaching addition and subtraction together helps to build those connections in the brain. Open-ended questions, like the one I have here, helps the kiddos not just focus on finding an answer. We found one answer, let's find another answer. How many more answers can you find? So you're learning about the process instead of just focusing on the answer. And then you can ask some follow-up questions that get them to extend their thinking. Addition patterns, like the one I'm showing you here with 7s, are something that kiddos really need to have practice using manipulatives with. Here, I would probably use something called Unifix cubes to have them build each of these and find what's happening. I wouldn't tell them what's happening, I'd ask them what's happening. Hopefully our kiddos would see that the cubes that are yellow are decreasing by 1 and the ones that are blue are increasing. So when the yellow decreases, the blue increases. They could then extend that knowledge to solve a problem like this. They might think about, well, if I add 2 to 5 and subtract 2 from 9, both numbers become 7. Well, doubles are so much easier to work with, so we know that our sum is going to be 14. Isaacs and Carroll's strategies in the book were numerous, so I picked 2 that I wanted us to look at. Counting on is a strategy we teach kiddos quite often. They take the number, like the number 8, and they count up from it. So 8, 9, 10, 11, 12. So the sum would be 12. Making 10 is another strategy we use quite often in elementary school. These are called 10 frames, and so we see that we have 9 blue counters and 6 red counters. But the students saw that if they moved one of the red counters up, we fill up a 10 frame. So now we have 10 plus 5, which gives us 15. So we know that 9 plus 6 is the same as 15. Games are so important. There is one concern with games. If you play them whole group, the kids tend to not get as much out of them. They're nervous about being wrong in front of others. If they go up against somebody that they know is faster than them, then they don't even try because they know, oh, they're going to get it anyway. So it's important to play games with a partner. Here's an example of a partner game that you could play, and you would definitely put the kids on like similar levels so they could help each other move up. You'd have one partner cover the corner of the triangle flashcard and the other partner's trying to figure out what it is that they have hidden. So they could think 42 divided by 6, or they could think 6 times what gives me 42, and then they uncover it to let them see if they got it correct. This is called a balance. It helps us see if what we said was true. 4 plus 2 is 6. Well, if the balance is balanced, if it's equal, then it will be true and they could check their work. We could also give our kids cards and have them sort them to create the different equations. And we know with fact families there would be 4 that they could create with these same cards. It's important that our kiddos have that counting, that conceptual knowledge. Then they can move to that reasoning, thinking logically, and then we can move to mastery. Many teachers try to do the drill and kill flashcards and things with their kids, trying to get the mastery better, but what they fail to understand is they don't have that foundation. It's like building a house without a foundation. It's not going to be sturdy. It's not going to last.